This is a review on mathematics, focusing on quadratic equations. The general or standard form of quadratic equation is ax squared plus bx plus c equal to 0, where a, b, and c are some numbers, and x is an unknown. Many times this x is something the questions ask for, and we will take a look soon at how we can solve for this x. Quadratic equation can be pretty straightforward, like in 5x squared plus 27x plus 10 equal to 0. Here a is 5, b is 27, and c is 10. It can also have some negative signs, like in 2x squared minus 9x minus 5 equal to 0. Here a is 2, b is minus 9, and c is minus 5. Sometimes quadratic equation can be less straightforward, like in x equal to 2x squared minus 10. But we can rearrange this, and it's gonna give us 2x squared minus x minus 10 equal to 0, and that is now a quadratic equation. Or it may use another unknown that is not x, like in 10y equal to 7y squared plus 3. We can rearrange this into 7y squared minus 10y plus 3 equal to 0. And now this is also a quadratic equation. The bottom line is that when an equation has only one type of unknown, and in this case it's either x or y, and the maximum power of that unknown is 2, it's likely that we are dealing with a quadratic equation. And now let's take a look at how we can solve for the unknown x or unknown y. There are many approaches that we may use to solve for x in the quadratic equations. I will review a few common ways in this video. For simple quadratic equations, we may use factoring with a little bit of guessing. This approach is fast and handy, especially when the first term a is equal to 1. When factoring, we pretty much try to break the equation into two simpler components or two factors. Each of the factors will contain a certain number, and when we multiply the two new numbers from these factors, it will be equal to a times c. But when we add two new numbers together, it will be equal to b. To make this a little more clear, let's take a look at an example. Here we have x squared plus 7x plus 10 equal to 0. To factor this, we have to think of two numbers. I will write it down as p and q. And we know that p times q will have to be equal to 1 times 10, which is 10. And p plus q have to be equal to 7. Alright, so from here I can think of plus 2 and plus 5. That means the factor is going to be x plus 2 times x plus 5 equal to 0. And from here we have to answer if x plus 2 equal to 0, that means x gonna be equal to minus 2. But if x plus 5 is equal to 0, that means x is going to be equal to minus 5. So this is the answer, minus 2 or minus 5. Let's try another example. Here we have x squared minus 9x minus 36 equal to 0. Again, we will think of two numbers, p and q. p times q will have to be equal to 1 times minus 36. So it's going to be minus 36. And p plus q has to be equal to minus 9. And from here, I can think of maybe minus 12 and plus 3. Minus 12 times plus 3 gonna be equal to minus 36. And minus 12 plus 3 is going to be minus 9, so this should be good. So the factor is going to be x minus 12 times x plus 3 equal to 0. So we have two answers over here again. If x minus 12 is equal to 0, then that means x gonna be equal to plus 12. And if x plus 3 is equal to 0, that means x going to be equal to minus 3. So the answer is plus 12 or minus 3. For a slightly more difficult quadratic, especially when the first term a is not equal to 1, we may still be able to solve it by factoring, but we might want to use a more systematic approach rather than just randomly guessing numbers. Still the same as before, it will be helpful to remember that the two new numbers in the factors when multiplied will equal to a times c, but when added to each other will equal to b. Let's take a look at an example. Here we have 5x squared plus 77x plus 30 equal to 0. The two new numbers in the factors when multiplied will be equal to 5 times 30 equal to 150, and when added to each other will be equal to 77. Now we have to list what can it be. So let's say 150, and it can come from 1 times 150, or 2 times 75, or 3 times 50, or 5 times 30, or 10 times 15. And only 2 and 75 that give P plus Q to be equal to 77. So we will use 2 and 75 in the factors. Next, we will write it down as 5x squared plus 2x from what we found over here, plus 75x again from what we found over here, and then plus 30, which is whatever left in the equation. And now we can split it into two parts, here and here. Now we can pull out the common factor, which is x. So we left with 5x plus 2 plus common factor over here gonna be 15. So 15 times 5x plus 2 equal to 0. And now the common factor is actually 5x plus 2. Pull it out again. So this is gonna be 5x plus 2 times x plus 15 equal to 0. So x is going to be equal to minus 2 over 5 or minus 15, and that is the answer. Let's take a look at another example. 2x squared minus 21x minus 36 equal to 0. The two numbers in the factor that we may be thinking of, P times Q, have to be equal to 2 times minus 36, and it is going to be minus 72. And P plus Q have to be equal to minus 21. So let's take a look at minus 72. In order to factor minus 22, one number has to be positive and another number has to be negative. So let's try factor out 72. It can come from 1 and 72, or 2 and 36, or 3 and 24, or 4 and 18, or 6 and 12, or 8 and 9. In order to add a couple of numbers up and give minus 21, we can use plus 3 and minus 24. And this is gonna be a pair that we will be interested in. And now we can write 2x squared plus 3x from over here, and then minus 24x from over here, and then minus 36 equal to 0. Now we will try to look at 2x squared plus 3x and minus 24x minus 36. We're gonna factor this out, and we're gonna have x 2x plus 3, and here it's gonna be minus 12 2x plus 3 equal to 0. And now this is the factor 2x plus 3. So here we're gonna have 2x plus 3 times x minus 12 equal to 0. So x is going to be equal to minus 3 over 2 or plus 12. And these are the answers. Another way to solve quadratic is to use formula. For equation ax squared plus bx plus c equal to 0, we can use this formula to solve for x. With plus and minus over here, x may have up to 2 possible answers, depending on the value under the square root. If b squared minus 4ac is positive, we may be dealing with 2 real numbers as possible answers. And if b squared minus 4ac is 0, we may be dealing with 1 real numbers as possible answers. And if b squared minus 4ac is negative, we may be dealing with 2 complex numbers as the possible answers. Now let's take a look at an example. Here we have 6x squared plus 11x minus 35 equal to 0. We're gonna be trying this formula to solve for x. So x gonna be equal to minus 11 plus minus square root of 121 minus 4, 6 minus 35 divided by 2 and 6. So x gonna be equal to minus 11 plus and minus square root of, let's see, 121 plus 840 divided by 12. And 121 plus 840 is 961. And let me see, square root of 961, I think it's 31. So it should be minus 11 plus and minus 31 divided by 12. So if it is minus 11 plus 31 divided by 12, we're gonna have 20 over 12, and that's gonna be equal to 5 over 3, or minus 11 minus 31 divided by 12 gonna give us minus 42 divided by 12, and it's going to be minus 7 over 2. So the answer is going to be 5 over 3 or minus 7 over 2. Let's take a look at another example. Here we have x squared minus 4x plus 6 equal to 0. Again, we're gonna try using this formula to solve for x. And x gonna be equal to 4 plus minus square root of 16 minus 4, 1, 6 divided by 2 times 1. And that means x gonna be equal to 4 plus minus square root of 16 minus 24 divided by 2. 16 minus 24 gonna give us minus 8. That means we're gonna be dealing with complex numbers. So x gonna be equal to 4 plus minus square root of minus 8 divided by 2. And that's gonna be equal to 4 plus minus root 8i divided by 2. And that means x gonna be equal to 4 plus and minus 2 root 2i divided by 2. And it's gonna be equal to 2 plus or minus square root 2i. So that means x gonna be equal to 2 plus square root 2i or 2 minus square root 2i. And these are the answers. Now we will go over some special cases of the quadratic equation. This first case is when we come across a perfect square and is equal to 0. The general form would be ax plus b squared equal to 0. A and b are some numbers and x is an unknown. Or it can be in this form, a squared x squared plus 2abx plus b squared equal to 0. In this case, x will be equal to minus b over a. We will have only one answer here for this quadratic. Let's take a look at an example. Here we have x squared plus 10x plus 25 equal to 0. You may solve this by factoring, but it may be faster when we notice that this is actually a perfect square. In the first term x squared, we have 1 over here. It is 1 square. That means a is equal to 1. In the second term, we have 10. It means 2 times 1 times 5. So a is equal to 1, b is equal to 5. And the third term, 25, it is 5 square. That means b is equal to 5. Once we notice that, we will know that x gonna be equal to minus b over a. So the answer is going to be minus 5. Let's take a look at another example. Let's try 9x squared plus 30x plus 25 equal to 0. The first term is 9. It is t squared. That means a is equal to 3. The second term is 30. It is 2 times 3 times 5. So a is equal to 3. b is equal to 5. The third term 25 is 5 squared. So b is equal to 5. Now we know that x gonna be equal to minus b over a. So it's going to be minus 5 over 3, which is the answer here. The next special case is also when we have a perfect square that is equal to 0, but it may involve a negative sign this time. The general form would be ax minus b squared equal to 0. A and b are some numbers and x is an unknown. Or it can be a squared x squared minus 2abx plus b squared equal to 0. In this case, x will be equal to plus b over a. Again, one answer. Let's take a look at an example. Here we have x squared minus 6x plus 9 equal to 0. Again, you may solve this by factoring, but it may be faster when we notice that this is actually a perfect square. In the first term, we have 1. That means this is 1 square, and a is equal to 1. On the second term, we have 6. That means it is 2 times 1 times 3. So a is equal to 1, b is equal to 3. And for the third term is 9. So it is 3 squared. That means b is equal to 3. Notice that we have negative sign over here. So x gonna be equal to plus b over a. And the answer is 3. Let's try another example. Here we have 4x squared minus 28x plus 49 equal to 0. This is also a perfect square. For 4, it is 2 squared. So a is equal to 2. For 28, it is 2 times 2 times 7. So a is equal to 2, b is equal to 7. For the third one, 49, it is 7 squared. So b is equal to 7. Again, notice this negative sign over here. That means x gonna be equal to plus b over a. 7 over 2 is the answer here. Now let's try the third case. This time it is also a perfect square, but not equal to 0. The general form would be ax plus b squared equal to c. A, b, and c are some numbers, and x is an unknown. To solve something like this, we may take a square root. Let's take a look at what I mean by that. Let's say we have 5x plus t squared equal to 49. So in the first step, I will try to take the square root on both sides. And we're gonna get square root of 5x plus 3 squared equal to square root of 49. And when we take square root of something square, we're gonna get the absolute value of that. So that means we will have absolute value of 5x plus 3 equal to 7, which means 5x plus 3 gonna be equal to plus or minus 7. So in the first case, 5x plus 3 equal to plus 7. X gonna be equal to 4 over 5. And if 5x plus 3 equal to minus 7, x gonna be equal to minus 2. So these two are the answer here. Let's take a look at another special case. I call this difference of squares. The general form of this would be a squared x squared minus b squared equal to 0. Or we can split this into ax plus b times ax minus b equal to 0. That means x gonna be equal to plus or minus b over a. We have two answers here, both positive and negative terms. Let's take a look at an example. Here we have 9x squared minus 49 equal to 0. We can split this by factoring. It's going to be 3x plus 7 times 3x minus 7 equal to 0. Or we may notice that this is a difference of squares, which means 9 gonna be equal to 3 squared. So a is equal to 3, and 47 is 7 squared. So b is equal to 7. From here, x going to be equal to plus 7 over 3 or minus 7 over 3, and these are the answer. Now let's try a practice question. Here, if 7 and minus 3 are the solution for x, which of the following could be the correct equation? So this time they give us answers and looking for the equation. So we are going backwards over here. So let's start with what they give us. X is equal to 7 and x is equal to minus 3. That means x minus 7 equal to 0 and x plus 3 equal to 0 too. That means x minus 7 times x plus 3 is equal to 0, which means x squared plus 3x minus 7x minus 21 equal to 0. So that means x squared minus 4x minus 21 is equal to 0. So that's the equation. Now we have to check A, B, C, or D. Give that correct equation. So I'm gonna delete this first. Alright. And now I'm gonna move this up to here. And then we can check each of the multiple choice. Let's start with the first one. So the first one gonna give us x squared minus 4x equal to 21. That means x squared minus 4x minus 21 equal to 0. That looks correct. So let's try the next one. The next one gonna be x squared plus 4x equal to 21. That means x squared plus 4x minus 21 equal to 0. This is not correct. Alright, let's see C. X squared minus 4x equal to minus 21. That means x squared minus 4x plus 21 equal to 0. That also not correct. Alright, the last one. This is going to be x squared plus 4x equal to minus 21. That means x squared plus 4x plus 21 equal to 0. Also not correct. So the correct answer is A. That is all for the review of quadratic equations. We went over a lot of things here. Go over this video again if you need to and practice more. Good luck!